Okay, so in question 10 it tells us that two sequences are generated by the recurrence relations un plus 1 equals a un plus 10 and vn even, so sometimes if we've got two the second one will be called v, so vn plus 1 equals a squared vn plus 16. And we're also told in the question that the two sequences approach the same limit. Okay, so these two sequences have both got the same limit. And we're asked to determine the value of a and then evaluate, so work out the limit. So first thing I know is that I know my limit formula is b over 1 minus a. So for the u recurrence relation, the limit formula will be 10 over 1 minus a. And for the v recurrence relation, the limit formula would work out as 16 over 1 minus a squared. Okay, so hopefully that's straightforward enough. But then what the question also has told us is that the limits are the same. So what that means is, it means that we can say that 10 divided by 1 minus a must be equal to 16 divided by 1 minus a squared. Okay, now from there we just need to solve this equation for a. The first thing that I would recommend you do is cross multiply, so bring this up to here. So I would have 10 times 1 minus a squared. And we're also bringing this up to here, so I would have that equal to 16 times 1 minus a. Okay, we're then going to have to multiply that out. So 10 minus 10a squared equals 16 minus 16a. And anytime we've got a quadratic equation, which this is, to solve it we want it equal to 0, and then we're either going to factorise it or use the formula. So if I want this equal to 0, I'm going to put these onto the right hand side. So I'm going to have 10a squared, I'm going to have minus 16a, and I'm going to have plus 6, because it would be 16 take away that 10. We then need to factorise it. Take out a common factor of 2 will make it a little bit easier to factorise. Okay, because although it looks like quite a complicated trinomial, actually once we've got that common factor of 2 out, to get 5a squared we can only have 5a and a. To get 3 we can only have 1 and 3. And if we're aiming for 8, we probably want the 3 there and the 1 there. And this is a positive, but this is a negative. So we're going to make them both negative, and let's just double check. That would give me minus 3a minus 5a, which is indeed the minus 8a that we are looking for. So if that's set equal to 0, the 2 obviously can't be 0, but what we would have is we would have 5a minus 3 equals 0, and we would have a minus 1 equals 0. Now if we solve both of those, we would get a equals 3/5, and we would get a equals 1. But you're told in the question, remember, that the recurrence relations, both of these recurrence relations, have a limit. So only one of these values of a will give a limit, and that's this one here. Because a limit exists, remember a limit exists when a is between 1 and minus 1. Okay. Which means that a cannot be equal to 1. Therefore, here a can be 3/5 only. And now that you know what the value of a is, I'm sure you're going to be able to work out the limit, evaluate the limit from there.